So we have to quantify the influence of the selected parameters and also their relations, and this is known as widening of factor relation. Then we come to the term gray control. So how a system is going to behave, and so that we can predict the future behavior, so that this prediction values can be fed into the system, so that we can control the system. So this is like a closed loop system. In an open loop system, we don't have any feedback, so we cannot control the system. But in the closed loop system, we have a feedback that is fed into the system again, and then based on that, corrections has to be carried out, so that a complete control over the system can be obtained. So in order to predict the future behavior of the system or the model, we are going to feed the predicted value into the system, so that this total system can be controlled. So this is an overview of the gray system theory. So two important factors that we have are the uncertainty in the systems and the incomplete information that is available in the data. So the uncertainty may be because of the system behavior, system boundaries, system elements. The incomplete information because of how you are going to perceive things or perceive the readings. So from the incomplete informations, we are going to develop a model, and that is to be used for prediction, and prediction is going to be fed into the system for making some decisions. Now, what is the need for this gray relational analysis? For what purpose we are going to use this gray relational analysis? So this gray relational analysis is specifically useful in determining the ideal conditions. The ideal conditions are optimum conditions of different input factors that we are going to consider in a study or an experimental study, so that the best quality characteristics can be obtained. The best quality characteristics are nothing but the outputs. The quality characteristics are the outputs. For example, energy consumed, surface roughness, material removal rate, flank wear, cutting force. Likewise, whether it may be smaller the best or larger the best, that's the next thing. But whatever the quality characteristics, but we have to obtain the best out of the quality characteristics, and for this we have to identify a optimum level setting of input factors, and that is carried out by means of this gray relational analysis. So another important need of this gray relational analysis is the performance of a complex process can be evaluated or judged based on the data that has a meager information. The meager information is a partial information or a incomplete information. The meager is with the lower information. The data has a lower information. Even though it has the lower information, we are going to evaluate the performance of a complex process. That is, we are going to judge or going to make a decision. So apart from the optimization techniques, this gray relational analysis is specifically important, and it is effective in deriving the optimum conditions or the ideal conditions when we are going to consider more than one output quality characteristics. In Taguchi, it is specifically useful for single objective optimization. There also we can use multi-objective, but this gray relational analysis is specifically effective for the multi-objective optimization approach. Here we can have some weightages. For example, if I am going to consider three output quality characteristics, for example, material removal rate, feed rate, and depth of cut, the material removal rate is mainly characteristic by the tool performance. So if the tool gets weared out, the amount of material removed will be lower and also the surface roughness will be higher. So I have to give a larger weightage to the tool wear, for example 60% or 50%. Then in assembly, the surface finish plays a vital role. So the next importance should be given to surface roughness, and the final importance should be given to the metal removal rate. But if it is a rough operations, then material removal rate should be given the most importance. So where we are going to apply this technique, in which process, so that decides how much importance that we have to give to the quality characteristics, and based on that the weightages may be arrived. So the steps that is to be followed in gray relational analysis. The first one is the data pre-processing. We have to pre-process this data, then only we can analyze the experimental data. Then comes the normalizing data. You have to normalize. For example, the surface roughness will be in microns. For example, 0.03, 0.001, 0.05, likewise. If I'm going to consider material removal, then it may be 1.8, 2.4, 3.6, or 1.1, likewise. If I'm going to consider cutting forces, it will be 110, 112, 114, likewise. So the first step in normalizing, what we are going to do is we have to convert all these readings in between 0